Eric,
Hey man, going well, going well. How are you?
good. Tell me about yourself. Give me some background to who you are.
Who I am. Let's see. Well, I'll start with work background. How's that?
Yeah,
So,
yeah.
I started working for the federal government right out of college. Actually started when I was in college, in the co-op program. They hired me on. Worked.
I was a co-op too. We're
Oh yeah,
co-op.
yeah, yeah.
No, continue.
Which yeah, it. I mean, it ultimately led to where I'm at today. So it was certainly a great experience and a great thing to have. I did that for about 6 years for a particular part of the government. Then I transitioned over to DHS, and I was with National Program and Protection Directorate, which then became Cybersecurity Infrastructure Security Agency, so CISA. So I did that for about 12 years, 11 or 12 years. So a total of about 17 years in civil service before I made a career change 3 years ago here in about a month um, to a life of sales at Elastic. So,
Yeah, and we're gonna have to do that
all
on
right.
another time. That'll be a good discussion, that transition. But
Yeah,
cool. Based out of
I am in Pensacola. Yeah,
Pensacola. Nice.
been here most of my life, actually.
Nice. Cool. All right. So today, I don't know if you've heard of it, but AI is being discussed in a few places these days, and we are really excited at Elastic about it, and you showed me a demo, and I'm very excited to show this demo. It's really awesome, like our versioning and everything. We are progressing fast in the world. But yeah, tell me, like, what is this demo? What are you going to share?
Yeah, well, just to take a step back,
Yeah,
to
yeah.
your point about Gen AI sort of being everywhere, right? Like it's the buzz, it's the new buzzword, right? But supporting the government both on the federal civilian side and the DoD side, when Elastic first started putting effort into really making an earnest effort to get into the Gen AI space. The government was very infantile in their utilization of Gen AI, and that's just nature of the government, right? Proceed cautiously and those kinds of things. But within the past year, I've noticed in a lot of the customers that I support, they've really leaned into how can we take advantage of Gen AI, right? Whether that be run it in a secured cloud instance, running it locally. How can we take advantage of it and derive, operational insights and that kind of thing from the data that we have utilizing Gen AI. So it's been really nice to see that there's a lot of momentum on the government side to actually try to make use of this, right? And so that's really nice to see. And that was sort of the genesis of this demo that I put together for this particular customer. A lot of people see Elastic or know Elastic from our solutions, right? Whether it's security, SIEM and XDR, or observability, and that's really as far as people's knowledge of Elastic goes in a lot of cases, right? And so it was very important to us to show this customer that hey, we are a data platform, right? Which makes extensive use of AI and generative AI if that is something that you're looking to use, right? So we're a data platform. Data is data to us. Doesn't matter, if it's structured or unstructured. It doesn't have to be, security or telemetry based. It's just data to us, right? And we wanted to show, hey, you could do some interesting things with just plain text data, right? Like just unstructured documents, news articles, and things like that. And so that's where this demo really was. That was
Yeah.
really the genesis of this demo.
And that's a great point. We are so well known in the security and observability world, but we are a data platform. We are a search platform. We store data. And the amount of times I hear the question, like, well, what do you guys have behind you? Like, what's your database? And I say, it's us. And they're like, you don't understand what databases are. Like, no, you don't understand us. Like, you don't understand, like, that we are a search platform. And while we've learned as we've used search and we've started to talk to more and more people, realized a lot of people use us for observability and a lot of people use us for security. But at the end of the day, it's a search platform. The value is bringing any data set, being able to search it incredibly fast, unstructured data especially, that's very much a sweet spot. And you look at Gen AI and unstructured data, and they really match well. And there's a huge value. And that's why I feel like there's such value, such excitement at Elastic as we move towards this AI world.
Yeah, and really with the most recent release, 8.14, we actually make it really easy to get those sort of generative AI insights from your data, right? You don't have to be a developer to get some use out of your data and really find out what's in your data and, have those question and answering kind of capabilities. So that was another reason that we wanted to show those customers like, hey, just bring it in and we'll show you the cool things that you can do with it.
Cool. Well, let's check this out.
All right. Alrighty. So this particular customer or this particular demo, we wanted to show that you can take, again, any kind of data, make it useful with a minimum of effort, right? Yeah, you can worry about schemas and index mappings and these kinds of things. And those are important, but we wanted to show that, hey, just bring the data in and you can do something with it, right? And we wanted to show that with data that's not security or telemetry based, right? Not machine to machine kind of data. We wanted to show that you can actually do this with any kind of data. And to that end, we created a demo that gives us the ability to pull in news articles from sites bordering, from states bordering Mexico. So California, New Mexico, Arizona, and Texas. And we wanted to show that, hey, we can pull in news articles related to fentanyl arrests and then actually do something with that data. Put it on a map, show you where these arrests are taking place, and show you how potentially you can actually see how, if there are any patterns or how these things are migrating, from state to state or within a state from county to county. And so the first order of business, we pulled in all these news articles related to fentanyl arrests. We extracted some information like the size of the the size of the seizure, right? Both in grams or number of pills, whichever one the article specified. We pulled in some information about the county and that kind of stuff where the arrest took place, and from there we actually use what's called an enrichment pipeline. So when we bring data into Elasticsearch, we have the ability to create what are called ingest pipelines, which gives you the ability to create processors that will do something with the data, right? Mutate the data, change it, add to it. And in that vein, we use an enrichment pipeline to add the coordinates of the county where this actually took place, right? Where the arrest took place. So we wanted to be able to show this on a map. So we have to have some sort of geospatial element, right? And so I have an index of US counties and the center point of those counties and the coordinates of those counties, right? So what we did is we matched up the incoming documents, the county, with the county index that I already have stored or that I actually stored for this particular demo. And then when I have a match, I then pull the coordinates from my internal index and then add that to the document as it's incoming. So we've got the article here, we run it through an ingest pipeline, and now we've got the article plus the geolocation, right? The geospatial component of these documents where this arrest took place.
Okay. So high level, everything I'm seeing here. So I'm seeing on my lefts and rights are really bad. On the right side, the end result in Elastic, some maps that you're going to show us, and some graphs, and some AI stuff as well. On the left is the raw data, which is newspapers. You download newspapers, and every newspaper you put on, you add a metadata tag saying this is the county it's from. How much effort was it to do that process? Beginning
So
to end?
there was a little bit of effort in that the data that we gathered wasn't clean, and there are ways to set it up so that it's a little easier, but by and large it was a matter of ingesting the PDF documents, right? Once I have the enrichment pipeline in place where I get to specify this incoming document match this part of this document with this other index that I have to pull that geospatial component into the document. Once that was squared away, it was just a matter of ingesting the documents, and Elasticsearch handled the rest.
Okay. Tell me, how did you choose the newspapers?
So we actually worked with We actually worked with a partner on this opportunity. They basically, I don't know how they found them, but essentially they were looking for articles related to fentanyl arrests. Right. So they pulled the documents, they created these documents, they pulled them from the news articles and created PDFs, and then we processed the PDFs to get the data into Elasticsearch. Elasticsearch can do that natively, or there are other tools like FS Crawler that can do it as well. We could also actually have set up a web crawler, right, to go out and crawl these news sites and these news articles if we wanted to do that. And that's actually something that you would do if you were doing this on a continual basis, right? Constantly going out, polling these sites, finding these articles and ingesting them, sort of automatically.
Okay. Makes sense. That makes sense. Now,
Yeah, I'm sorry, go ahead.
yeah, what do you have to do to set up this ingest pipeline? What did you build for that? Do you have an Elastic agent that you created? Did you send it in via like a Python script?
So that's a good point, and that's a good distinction with the agent, right? A lot of the agents and the data integrations that come with agents already set these things up for you, for a lot of common log formats and data formats and that kind of thing. For this particular use case, we didn't have a data integration or something out of the box for this capability. So I actually created the enrichment pipeline myself. It's very straightforward. It's easy to do. And I did it in a matter of a few minutes. You have to some degree understand the data and what you're trying to get out of the data and get into the data as it comes into Elasticsearch, but it's a pretty straightforward process. You can do it programmatically, to your point, right? With through Python scripts or whatever. You can also do it in a visual kind of way inside Kibana as well. So there's a lot of flexibility there in how you set those up.
Okay, awesome. All right, let's.
Okay.
Yeah,
Yeah.
continue.
And so there were two components to this demo. One was just showing that we can take this data, enrich it in some way, right? And in this case with geospatial coordinates, and then display it on a map and show it in an aggregated form to get an idea of where things are taking place, right? And we created a dashboard that's got a few little visualizations on it. And then the second half is actually how we can take advantage of generative AI, and in particular retrieval-augmented generation, to actually ask and receive answers about the data that we're looking at. So the first thing that I'll do is I'll jump into the dashboard. Let me jump into Discover first. So this is Kibana for those watching who don't recognize this. This is actually Kibana. This is the web UI front end to Elasticsearch. You can see here that I've ingested 157 documents. And just to take a look at the documents, we've got some basic information about the document. We actually have the actual content of the document itself, including these things that we don't really need, right? All these affiliate links and that kind of thing. And then some information, just that we've extracted from the document: number of arrests, how many pills were seized, how many grams, if that information was in the document, how many grams of fentanyl were seized. And we also have our geospatial element that we've added, right? This was where this came from the enrichment processor that we set up as the data is coming in. So this is actually geospatial coordinate of the center point of Collin County, whatever state we're in, Texas, right? So that's what the data looks like. All 157 documents look just like this. And so we created a dashboard. Dashboards are table stakes, really, for any data analysis platform. But we wanted to show that, hey, even though it's essentially free-form text, right? It's unstructured to a large degree, you can still make use of it, right? The first thing that I did was a simple visualization where we have each state that we've collected documents from, what percentage of the total news articles these states make up, and then take that a step further and show what percentage of the total documents each county and each state are actually looking for, right? And one thing that you can actually do, or to click on California, you can see that I've got a filter applied here. And so now my entire dashboard is filtered based on California. You can see we had other states in here before. Now it's only related to California. Another thing that I did, and this is a fairly new visualization here on this piece, or we've got the states and the counties. It's essentially a multi-metric kind of visualization where I took the number of pills that were seized in every given county. I'm sorry, number of pills that were seized, broke that down by county, and then multiplied that number of pills by the street price of fentanyl, right? And so the idea was, hey, to get a heat map kind of view, like where are my hot spots for fentanyl seizures and arrests, right? And then I ordered it by the number of people that were arrested, just because I wanted, to have some sort of order to this. But you can see, right, that we've got this visual representation of where these arrests are taking place, and how much money in terms of street value these arrests have, taken off the streets and that kind of thing. So I thought that would be an interesting thing to show. And then from, this data it's nice to see this like this. This gives us some valuable information around these arrests and the things that are happening. But it's also really nice to be able to see it on a map. And so if we look at this, I can actually hover over one of these. And you can see it as one of 5, right? So these are the actual documents that are ingested, and because of that geospatial component that we added via enrichment at ingest time or at index time, I can now display all of these on a map, right? And so I can see the content of the document. I can see the number of arrests, the number of pills. This document didn't list any number of pills. It did list, 113 grams were seized, and it's El Paso County. And because there are 5 of them in this county, I can cycle through these if I want.
So as you look at this, you'd also have timestamps as well. You can look at it historically. If you had historical data, has it changed? Machine learning as well, like once you bring in large sets of data, being able to assess, is one county getting more than normal, being able to assess that, and keeping this real time or old time as well.
Yeah, that's actually a really good segue into the next layer, right? And on these maps, you can add layers and you can just stack them on top of one another, or you can use them individually. And that was actually a really good segue into this, in terms of looking at this as time series based data, right? If I have months or years of data that have timestamps to them, I can aggregate this data. You can see that I've got, what is this? 9 fentanyl arrests in Maricopa County for these, this time period that we captured these documents. If this were a long set of time series based data, I could, to your point, actually cycle through this, let's say a day at a time or a month at a time, and actually see how the aggregations of these arrests move, right? I could see as they move, from county to county or state to state, or if there are less and less arrests taking place or more and more. And so that's another valuable way to be able to display this, right? You don't get that context from these types of visualizations, right? You can only get that when you look at it from a geospatial perspective.
What's the scale limits on this? And I'm giving you a softball on this one, of course, but tell me, like, can we only do fentanyl to the county level for so many years? What like how big is this data set, and how many of these kind of data sets could you put in Elastic and have the speed that I'm seeing here?
You give me a multifaceted baseball softball question. Yeah, so this particular set, I think you saw was 157 documents. So it's by all respects, it's a very small data set. Elastic, our tagline is speed, scale, and relevance. Key to this, your question being scale. Elastic will run on anything as small as a Raspberry Pi. I'm actually doing that at home, all the way up to petabytes in scale. The scale of the data doesn't matter. We can support sub-second response time across, petabytes of data. And then, we see this with a lot of customers too, meeting RMF retention requirements and that sort of thing, where there's a requirement to keep the data for a certain period of time. And we give you a lot of flexibility in how you do that through data tiering, right? We support the traditional hot, warm, cold data tiers, but we also support something called the frozen tier, which gives you the ability to store large amounts of data for a long period of time on very low cost, object compatible storage. So that gives you the ability to do those look backs, over years and years and years of data without having to rehydrate that data. So from a scale perspective, you never want to say it's unlimited, but I don't think we've yet found, a practical limitation of how far we can scale.
Cool. All right. I think you want to share some AI stuff too.
Yes.
I don't know if that you want to go get to that now, but
Yeah, we'll jump into
I,
that.
and while you go through that, one question I have is, like Elastic AI has been transitioning. I'm curious your experience with the newest version, which I believe is 8.14 that you're using here. And I believe you did some AI in the past. I'd love you to share like what the differences is, what you've seen as different.
So, you mean in like what we're looking at here with Playground and
Yeah, your experience of building. I mean, you didn't even do RAG. RAG is. I know you did some ML on some airplane stuff back in the day. So,
okay, yeah. So we do have, a full suite of ML capabilities from anomaly detection to outlier detection, which I use both of those quite a bit to your point with the aviation data that I'm doing sort of as my pet project. So we've supported those ML kinds of jobs for a long time. Again, something as simple as anomaly detection, where you're looking at a value or a set of values over a period of time and then alerting where those things sort of deviate from a baseline. And we've moved into, right, this Gen AI capability where we're sort of offloading some of um, that computation from strictly ML to large language models, right, where we can actually ask questions about the data and get useful results. And you'll see here, I think in this part of the demo, how valuable that can be, even from the perspective of just wanting to see what I can get out of my data. Like what's there, what questions can I ask without having to know, the answer is in this field or it's this value that I'm looking for. Being able to ask those natural language kind of questions. Elastic has put a ton of engineering effort into moving that ML and AI capability forward and making it very valuable for people
I,
to use.
I know where you're going with this. Before we go on, what is an index? Explain search for index, what we're looking at here and why that's important.
Yeah, so the index is actually in that first slide that I showed earlier, where we had the data coming in and enrichment, and it gets written to Elasticsearch. An index is essentially the basic unit of. It's not entirely true, but for the purpose of this conversation, right? It's sort of the foundational scaffolding of being able to provide a search experience, right? So it's where the data is written, it's where the data is stored, it's what Elasticsearch uses to query and find and return
So,
the data.
so if your Elastic cluster has some of this data and then say some, I don't know, metrics of your computer data and maybe another drug data, you can look in the indices and choose which one you want to look at specifically, or a mix of them is what
That's
it is.
exactly right. Yep. And we do support something called data views, right, which gives you the ability to create essentially a regex pattern or a wildcard enabled pattern, right, that gives you the ability to query multiple indices at the same time.
Okay.
You can see here, right, that there's a bunch of indexes that I can choose from. So I'll actually just pick the one that I showed earlier where those documents were. I could add additional indexes if I want, but I'll click start. And this is actually something that came out in Elastic 8.14. Prior to this, there needed to be some degree of development work, right? Whether it be through Python code or whatever, to actually search data from Elasticsearch and then provide it as context to an LLM. And so with 8.14, we've sort of taken that and condensed that into this capability called Playground, where you can actually ingest data, search that data, and then provide that to a large language model. And so that's what I'll do here. I'll pick a model. I'm picking GPT-4 from OpenAI. I actually have a prompt. So in the instructions panel here, I can actually tell the LLM how I want it to respond to questions. I'm saying, hey, you're a question answering related to fentanyl arrests. Any responses should take into consideration the number of arrests and the arresting authority, and basically just putting guardrails around the response that I want. I will change if it's not already set. Okay. I'm just going to return 3 documents. So when I actually ask this a question, this Playground is going to go out, search Elasticsearch, return the 3 most relevant documents, and then send that off to the LLM. The first question that I will ask, now keep in mind, we haven't processed this data other than adding the geospatial component, right? So the real value here is we've just got a big blob of text in these articles, and I can actually ask questions. I don't have to say, return all documents where this field equals this value or that kind of thing, right? So I can actually just say, have there been any recent arrests in Arizona where multiple people were arrested? Name those arrested and the arresting authority if known. So I'll run this, and you see right away, I get a response saying that the Lee County Drug Task Force arrested 2 individuals, those people who are named, and how much was seized, right? And you can see that that's partly because I told it to give me the number of arrests and information about the size of the fentanyl seizure, right? So it knows that, hey, I want this information. It's in the document that we provided, and you can actually see that it shows me the citation. So when I asked this question, it went to Elasticsearch and found this document. If I wanted to look at the snippet, I could actually see part of the document, and you can see the value right away, right? If I'm trying to find this, just looking through this document, this is a mess, right? And again, as I pointed out before, there's affiliate links and all this kind of stuff that you have to wade through to really see. But being able to just pass this to the LLM wades through all that and gives you the answer that you're looking for. And I'll just show one more. I know I want to keep this brief. Show one more question. I can just say, what was the largest seizure in California? So I can send this. I'll get an answer back. The largest seizure in California, more than 4.2 kilos of fentanyl in the Tenderloin neighborhood, right? And then, of course, there's just some other information, sort of editorial information from the article, but I got the answer that I wanted, right? And there are a lot of things that you can do in terms of, you could run these documents through Elastic's Learn Sparse Encoder semantic model, right? And actually get more semantically relevant results. There are things that you can do with your data for long-term capabilities like this, where you can actually prepare the data ahead of time and get even better, even more relevant results. But the beauty here with this playground is that I can just throw some documents in an index, point this playground at an index, and ask questions and get somewhere, right? So in terms of triaging documents for some investigation or whatever, right? Being able to ask the question and immediately have a document or two that I can hone in on. That's a really valuable capability. Speaking of long-term, kind of moving something like this to a long-term capability, if I'm the developer type, I can actually click the view code button here, and I can actually see the Python code with
this. I was just in shock.
Yeah, with the connection information for the OpenAI model, right? So I can actually just literally cut and paste this and have something in Python that I can utilize. Again, right, a short demo, pretty simple. Just wanted to be able to show this customer that, hey, these are the things that you can do that you couldn't do with Elastic 2 months ago.
Yeah,
right?
I mean, I would say this allows the average person to be a data scientist, period, full stop. The questions you're asking back in the day required pretty complex SQL commands, a lot of complexity. Like, I mean, even within Elastic, you have to do KQL or ESQL to do some of these commands, but but you write those commands because this is what you want. This is how you say that command in English. Say it in English, and it's giving you responses back. And whatever data set you're looking for.
Yeah, and it gives you the ability to get semantically relevant results, right? I mentioned the keyword search,
yes.
Searching for fields. Elastic natively gives you the ability to, I could search this content. I could just say, content equals, and then the search term that I want, but I don't get semantically relevant results unless I'm using, a semantic model, running this through the semantic model, or, providing this data as context to an LLM to get more, like I said, semantically relevant
an
result.
Actual answer, as opposed to
just a straight keyword term match.
Yeah,
exactly.
Yeah. So tell me, like, what, I mean, this blew me away when you showed this to me. I loved this, and this was pretty new to our newest version. This is the first. It says tech preview, so it hasn't even.
This is the absolute first iteration that's been available to preview with 8.4.
Which means we want people to tell us their opinions, their thoughts. How do we make this better? How do we make
Absolutely
it easy?
use it, play with it, beat it up, let us know.
Yeah.